value stream maps are great, but how do you use them in a low volume, high variation type of production? That really has a couple of challenges we need to discuss. Hello, I'm Tom. Welcome to my channel where we talk about continuous improvement in an industrial setting. And today's video, it is about value stream mapping, and it answers a viewer question on how do you actually value stream map when you have sort of this mixed type of manufacturing, right? So low individual volumes, high variation in what you're making, and that is a very good question because value stream mapping, it is meant for a high volume, low variation type of production, right? That is where it excels. So first off, be very careful what you actually want to measure and why you want to do a value stream map. So sort of against the grain of this video, the value stream map might not be the tool that you use in these environments, right? So what are you trying to measure? Now, when you are trying to measure things like how long does it normally take us from when an order is placed to when we deliver it to a customer, we really want to speed up that process of getting stuff out of the door, even though we are like almost a job shop and just make stuff on order. We sort of have those orders lying around for weeks. Well, in that case, definitely, yes, value stream maps can be a good thing. Just know what you're trying to find. Also know that the traditional way of counting work in progress, WIP, counting that in between the processes, and especially doing the very traditional, and I would for a high volume, low variation production really advise you to do this. Just walk the process from the end all the way upstream to the front of the process and just physically counting how much is there today. Just use it as a snapshot of the process. This will almost never work in a low volume, high mix production because the product that is at the last station is probably not even the same product. You may have 5 products down the production total process at any one moment. So, these are the difficulties when using value stream mapping. But what we can do is sort of 2 directions in how we can set up a value stream map. And so 2 ways of looking at it to have a more useful way to value stream map a high variation type of production. So the 2 main ideas are that you work with product families. So you don't really chase the one product because you have so many that multiple can be on the line. You're not going to see all of them. They're not by themselves very representative of what you're seeing. So divvy up all of your products into families that are sort of going through the same processes at a similar pace, right? They may not be the same products, but they are similar enough that you can take any one of them or just sort of put them all together when you do your measurements. And this way, of course, you will also go for the more important families, more important products, but you follow them that way and make a pretty traditional value stream map. Or we're going to map the process more than the product stream, right? A value stream map follows a product because that is the value component. But it does not focus too much on the processes. It just looks at what process is my value flowing through. Now, we can also switch this around. The tools are pretty similar, although, process mapping also has slightly its own ideas. But the concept of value stream mapping, it is also very nicely done in a process map where you look at what are my processes, how much work in progress is waiting in front of each of the processes, how utilized are my processes, things like that, right? So those are the 2 main streams. Now, when we go for product families, right, things to take into account. you should be looking at your most critical products here. Now, they will be in some family, but you have again a reason why you want to do a value stream map in the first place. If you do a value stream map just because your manager told you, do whatever you like, give them a picture, and forget about the rest, because honestly that is the worst reason ever to do a value stream map. Hopefully you are looking for something like, we are ticking off a particular customer, so now I want to know why it takes so long to make the products for them. You sort of know that making your bicycle only takes about a day or so if you would have an empty factory and just drive it through there and just have everything ready to manufacture. So how can it take us 3 months to make that order? Same for all kinds of products, right? This is usually a reason to start a value stream map. Or you have big quality defects, or you have big costs, but often, lead times, they are the most important, or huge inventory levels, which is sort of the companion of lead times. So do that with a product that is actually critical to you. But then also, very important, especially with these high variation type of environments, follow it from the order to the delivery. So don't just look at the production processes in a sort of a big process industry, which is generally high volume, not too much variation. Those type of industries, many value streams will be sort of made in production, more or less, right? So, well, there's a little bit of planning here, but they generally don't really take the actual order process into account, even though would be good, would be the proper way. It's in such environments pretty okay to do a value stream map just of your sort of supply chain part of the process. With a low volume, high variation type of process, really do the whole process, because what you will find is that the difference from order to even hit production in the first place, that is probably taking you a very long time. This may be because you are ordering all of the materials and they have very long lead times. Maybe it is because you just have a pretty poor quality ordering process and planning process. But it might also be, and these are things you want to find out, because your production is basically very filled up already. So it'll take a long time before planning will find a hole through the production process that they can put this new order through. Right? So these type of things, that is what you're really looking for when you're doing this value stream map for critical product families. The whole process. When you want to do something that looks a bit more like a traditional value stream map in a more high volume type of manufacturing, you go to more the process mapping. And this is interesting if you are not per se looking in the flow, the throughput of specific products, so delivery times to customers, but you are more looking for how can we increase total output of our factory, or we have a couple of bottlenecks that just seem to be clogging up the whole factory, and this factory can do more, right? If that is the assumption you have, then mapping out the process is a very good choice. But here we also have a couple of pointers to make sure it sort of works in this environment as well. And that is based on really count all of the stocks, all of that inventory you have as work in process. Not just for the product you are now following, because you're not really following a product, just how much inventory, how much work in progress is waiting for a specific part of your production process. So count all the different orders that are now sort of ready to take this machine as the next step. And you do that on all of the processes, all of the machines, processes in your layout. And these are sort of companions, check the total utilization of all of those sub-processes. So here we're not really looking for, and utilization when you do it in a typical VSM, and especially with the products or product families, it's a difficult part to really see. So you will not, if you follow just one product, you will not really see, that machine is over 90% of its capacity is being used, because this one product just uses a couple of hours a day, a week, something like that, of this machine, especially in a low volume, high variation type of setting. But when we do the process mapping, check the total utilization. So all of the products you're now pushing through it, how much time does it cost? And the easy way to do it is not to look at all of the planned products, but just look at the planning of a line, right? So how much of the day, of the week, is this machine planned in for anything, right? Not just for pure production, but also for cleaning and maintenance and breakdowns and what have you. But how much of the time is it manned? Is it busy? Because those lines that have 80 plus or even 90+% utilization rates in a high variation environment, they will be bottlenecks for sure, right? When you have a large chemical processing plant and you've got a couple of lines in there that are 90, 95%, maybe even 100%, but 95% utilized, they are generally the bottleneck, but people know it and the plant is just built around them. And you start optimizing that part of the process. And just the rest just has to make sure that one doesn't stop. Now, when you have that high variation, it's not as clear because that machine is not the clear bottleneck for all or most of your products. In total, it will be, but these might be a planning department or a pre-design department that sort of makes the molds that go into the big machines, stuff like that. It can be a very simple type of machine. If you read The Goal, right, by Eliyahu Goldratt, very nice and famous book, sort of on this, not really on value stream mapping, but sort of on the same concept. The oven is the one. So the oven is a sort of a simple process, but because all of the products need to go through it, it becomes this bottleneck. So really good concept to think about the total utilization of your processes and count all of the materials that are sort of waiting to go through it, whatever type of product they are. This way you will find your big bottlenecks, you will find the dragons in your production process. Then the other one, and you will get the same from the oven in the goal in that factory, changeover times. When you have a high variation type of organization, changeover times are killing. These are the things that will cause your planners to try to put big batches in there, your production people to hate to switch products, the whole expediting, or it's all creating a mess when your changeover times are high. When you can really do flying changeovers, the real single minute exchange of die, if you can do that, you don't really care too much anymore about what product is next. That is a state you need to go to when you want to have a lean, high variation process. So look at those changeover times. Any machine that has a high changeover time, a difficult and long changeover to do, and especially if you need to prep it well in advance, those are key areas for improvement. See, when you have that high variation and something didn't come out of a previous process, or an order of parts, it just shipped in too late, and at the last moment you have to switch to the next one in the line. If you have a small changeover time, you just do that, get that next one, give it sort of priority, and then do the product that you plan to do as soon as all the parts are in. That can only work if you don't need to prep for hours to make sure that you can run this product. So those are the things, if you, especially when you're looking at a high variation type of environment, look at them. And the thing is, you also want to look at them when you do a regular value stream map of a high volume production. But when you do run high volume, so when you run a batch for 2 days straight, then a changeover time of about 4 hours, that's an OEE loss, right? We lose some efficiency on that machine. And we can gain some efficiency if we can reduce the changeover time, which it's good. I mean, usually the machines are big, expensive, and also expensive per hour. So any hour we can shave off a cleaning or a product change or whatever, super. But they are not as critical, because you're only doing a few changeovers a week. Now, when you do a lot of changeovers, first reaction might be, well, that means that if you shave off 10 minutes times 20 times a week, that is a lot more than even an hour shaven off 3 times a week. But the main thing is, when you have this high variation demand on your factory, then having large changeovers, so long time, high difficulty, it will completely stifle your planning. You will not be able to react flexibly, which is needed in these type of factories. So when you do them, changeover time is a main priority, and you do it also, you look at utilization and your WIP levels before each of the machines to indicate those trouble areas, bottlenecks. The bottleneck might look like it should have plenty of capacity, but if you see a lot of product in front of it and a high utilization percentage, it is a bottleneck and it really warrants improvement of that process. Now, as a sort of a last tip, however and whenever you do a value stream map of especially these low volume products, you have to be careful in how you treat inventory. Normally, we express inventory in days, which is a very good way to do it in value stream mapping, and keep doing it here as well. But when we have a low volume product, a relatively small inventory somewhere may account to, I don't know, 30 days or so, because we hardly ever make it. So this may be something like a tenth of a batch when we make it, but because we make this product only once every 3 months, technically it becomes a 30-day inventory. That is not super useful to you. So put it in money as well, because that way you can add it up for products with very different volumes, and it will give you a much better comparison. And you don't really have average days anyway. Now, what you could do is to say we make so much turnover per year, so we divide the value by the yearly turnover, and then again we get sort of corrected days based on how much money is flowing, and you can express it in days of money flow. It may work, but if you do that, just put it in money, right? Don't stick to the absolute rule of we need to have it in days of flow. Make it in normal days of flow, because probably that's one of the reasons why you did the VSM in the first place. But also put it there in dollars, euros, yens, whatever, to show where the money is kept, where inventory freezes money in your process, or which parts are actually worth a lot and where you have large inventories. So keep those things in mind. When you have a low volume, high variation production, your first thought should not be value stream map. This tool was not designed for such environments. So be critical on what you actually want to measure and why you want to know those things. Now, if then you still want to know the flow of product through your factory, definitely can be very important for customer satisfaction or to see where you have bottlenecks and throughput problems. Think about, are we mainly interested in product speed, so delivery speed from order to customer? Then think of these product families to give it a bit of bulk when you do your value stream mapping. When you are more interested in the output of the factory, think more about the process mapping, and then go for utilization and changeover times to identify those bottlenecks. In any case, express your inventory not just in days, but also in money to give a much better comparison when you do a number of product families, for instance. Now, I hope that helps you to use value stream maps correctly in these high variation types of production. If it did, don't forget to hit that like button, and maybe even write a nice comment. Also, you see that questions, they get answers. I really do like making videos based on your questions, so write them down in the comments. how do you use continuous improvement, but also, what are your questions on various continuous improvement concepts? I'll be happily thinking about it, hopefully making a next video about that as well. For now, I wish you the best of luck mapping your value stream, and as always, don't forget to enjoy the continuous improvement journey.